Hello friends, I am Professor Tushar Gujarati and today we will discuss the topic that is digital to analog conversion. So let's start with this topic. So basically, uh, digital to analog conversion is very important when the data from computer devices is in digital form and we have to convert this digital form into analog form for analog devices. At that time we need digital to analog conversion. Okay, so here in the diagram one DAC is shown. DAC means what? Digital to analog converter. Okay, that digital to analog converter is shown in the diagram, and the input given to that digital to analog converter is binary input. Okay, you can see several number of lines are there, so it is called as binary input, and output is one single line, that is called as analog signal output. Okay, so here this is binary input. Okay, and we get one single line output, it is called as analog signal output. So this is the digital to analog conversion. So what happens in digital to analog conversion? The properly weighted voltages are summed up. Properly weighted voltages are summed up together to yield the analog output. Okay, so suppose 8-bit word is there, digital word. So there are 8 inputs are there. So all 8 input voltages are summed up to yield the single analog output voltage. Okay, this is the digital to analog conversion. So now here one example is shown. 3 weighted voltages are summed. 3 weighted voltages are summed. The 3-bit binary code is represented by the switches. Okay, so here you can check now. So here we are using 3-bit word, means we are using 3 switches. So like this is one switch, this is another switch, and this is another switch. Okay, so when the binary number is 110, let us assume binary number is 110. So when binary number is 1, at the time switch is closed, and when binary number is 0, at the time switch is open. Okay, so in this diagram there are 3-bit and 3 switches are shown. So most significant bit and least significant bit. So this is 1, this is 1, and this is 0. Okay, so when 1 is there, at the time switches are closed. Okay, and when 0 is there, at the time switch is open. So you can check that when it is 110, at the time center and bottom switches, bottom and center switch will be on, that is closed, and top switch will be open because it is 0. Okay, and that's why the addition will be 6 volts and our analog output will be 6 volts. So here you check the weights are given to some blocks. Okay, so the weight of this block is 1, weight of this block is 2, and weight of this block is 4. Okay, so here it is 1 and here it is 1. So if you multiply 1 into 2, you will get 2 here. Okay, and if you multiply this 1 into 4, you will get 4, and the addition of this you will get here 6. Okay, so the analog output voltage will be 6 in this case. So like this we can calculate analog output voltage. In actual case what happens, the switches are electronic and are set by the input binary code. So these switches are electronic switches. Okay, now this is one of the type of digital to analog converter which is called as R to R type digital to analog converter. This is called as ladder type of converter because you can see it looks like ladder. 2 horizontal lines are there and in between them vertical lines are there. That's why it is called as R to R ladder type of digital to analog converter. You can check here, there are many registers are provided. Some of them are having value R and some registers have value twice R. Okay, so this is actually 4-bit register. There are 4 inputs are there. B0, B1, B2 and B3, these are 4 inputs in this diagram. So this is B0, B1, B2 and B3. Like this there are 4 inputs. So here it is MSB and this is LSB. Okay. So this is also important. So when the input is 1, what will happen? At that time switch is closed. Okay, these switches are closed. Or when input is 1, what happens? This is connected like this. Okay. And when input is 0, at that time they are grounded like this. Okay. So there is ground position is also shown. So when input is 0, at the time it is ground, and when it is 1, at the time it is connected to output line. And also op-amp is shown over here. Okay, op-amp also has some resistor R. Okay, and we get here output voltage V output. Okay, so like this construction is there. It uses only 2 types of resistors as R and twice R. That's why it is called as R2R type of digital to analog converter. And input is given here Vs. This is input voltage, and here you will get output voltage V output. Okay, and in between them this circuit is used. Now let us assume that we are using word 0001. Okay, so here you can check this is 0001. So what is happen? So all the 3 bits are 0, that's why they are grounded, and only 1 bit is 1. Okay, that's why it is connected to output line. Okay, so like this the position of this example, that is 0001. Okay, only 1 is connected to output line. So actually this circuit acts as a voltage divider circuit. So you can check here it is V0 is written, here V1, V2 and V3. Okay, and here it is Vs. So every node acts as a here voltage divider circuit. That's why V0, whatever V0 is there, V0 is half of V1. Means whatever input is coming to it, it is divided here. So V0 is half of V1. Similarly V1 is half of V2. Okay. Similarly V2 is half of V3. Okay. And but V3 is equal to Vs. Okay. That's why we can write here also V2 is equal to half of Vs. Okay. And if you add all these voltages, then you will get V0 is equal to 1 by 8 of Vs. Okay. So V0 is 1 by 8 of Vs at that position, at this position. V0 is 1 by 8 of Vs. And now at output position, V output. So what is V output? V output is have this formula R upon twice R V0. Okay. So it has this resistor R and twice R. This twice R. That's why V output is equal to R upon twice R V0. And if you put value of V0 as 1 by 8 Vs, at that time you will get answer as 1 by 16 Vs. Okay. 1 by 16 Vs. So from this you understand that when V0 is 1 or when this line is 1, you will get output as 1 by 18. Sorry, 1 by 16. When B0 is 1. Okay. So like this you remember. So we'll go next slide. So our binary input is suppose 1 1 1, then our formula will be something like this. V output is equal to Vs into 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16. Okay, so like this will be our formula. And if you multiply it by binary numbers B3, B2, B1, B0, then you will get actual final answer. Okay, so Vs into B3 into 1 by 2, B2 into 1 by 4, B1 into 1 by 8 plus B0 into 1 by 16. Okay, this is our final formula. Okay, so just a minute, we'll check something. So here when B0 is 1, we are getting output as 1 by 16. Similarly, when B1 is 1, at that time we will get 1 by 8 as output. Okay, when B2 is 1, at that time we'll get 1 by 4 as output. Okay, and when B3 is 1, we'll get 1 by 2 as a output. Okay, so that's why we have taken in the formula the addition something like this: 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16. You can check the formula. So in this formula we have taken like this: 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16. Okay, now this is the example. An 8-bit R2R DAC has a V reference of 10 volt. The binary input is 1001111. Find our analog output voltage. Okay, so this is one method to find analog output voltage. We have to calculate first of all the analog input. Okay, so how we can find? We have to multiply each and every bit by 2 the power, like 1 into 2 raised to 7 plus 0 into 2 raised to 6 plus 0 into 2 raised to 5, 1 into 2 raised to 4. Like this we have to multiply each and every bit by some weight. Okay, and we will get answer as 155. And then we can calculate the analog output voltage as V output is equal to input into V reference divided by 256. So 256 means what? We have total bits 8 bits. Okay, so to the power 8 is equal to 256. That's why in the formula we will get 256. So input is 155 into V reference is 10 volts divided by 256, we will get answer as 6.05 volts. So 6.05 volts is the voltage we would expect on the analog output pin. Okay, so this is our answer, 6.05 volt. So can you calculate output voltage for 11111? If all bits are 111, what will be the output voltage? And can you justify? So you all of you try at your home and try to calculate and mention me in comment what is the answer for 111111 if all the 8 bits are 1. So what will be the answer? You just mention in the comment box. Okay. There is another way of solving example 1. Same example can be solved with the help of this formula. You have to use this formula: V output is equal to V reference, and multiply every bit by 1 by 2, 1 by 4, 1 by 8, 1 by 16 up to 1 by 2 raised to 1 up to 1 divided by 256. Okay, this is the formula you have to use. You have to only put here values of bits 1 0 0 1 0 0, and you will get answer very easily, 6.0546 volts. Okay, this is also simple way to solve this problem. Okay, so like this we have studied today digital to analog conversion, and we have studied the very important, that is R2R ladder type of digital to analog converter. Okay, so thank you so much all of you for watching this video.